All right. Adjust the levels a little bit here. Hopefully those are okay. Let me know if the mix is good, chat. But welcome back. Another week, more Haskell hacking ready to go down. I think we're nearing somewhere in the middle of making the authoring tools for this interactive fiction game engine. We're getting we're making progress. We're making progress. I don't know if we're near the end, but we're making progress on that tool so that we will be able to author interactive fiction games using use our engine to play them. And I think we're making good progress. I hope we're going to get done soon so we can try it out. But without further ado, let's fire up the builder and get going. So that's an adventure engine. If you're just tuning in for the first time, all the code that you're going to see here tonight on the stream lives on the GitHubs. I'm Agent Ultra, and it's under my account, under Agent Ultra there. Adventure Dash Engine. Very, very simple. All right, here you go. So if you want to hack around with it, mess around, take a cut, whatever, it's there for your enjoyment and entertainment, learningness. If you want to learn from it, that's cool too. We all like Haskell here, I hope. I know I do. Took me a long time to get good enough at it that I felt comfortable. But we're good now. Okay, so first things first, I'm looking at the parser here, and my linter is asking me to like not stop repeating myself because I've got like the exact same code here, the exact same code here, so we can lift this into a property label parser. And that's just going to return some text. All right, like that. Not passer. Thank you very much. Ooh, no, it needs to take... It throws it all away. It just consumes it. But yeah. So it actually is just a parser unit. Label. Right, and then we can pull this up here. The common element between the two. I think we can just use like this. We might need like a void in front here, but I'm just gonna do it like that. And then we can get rid of this here. Cool. And linter's happy with that, so that's nice. We'll make a small little commit for that. I'll call it will refactor maker minor deduplication. Okay. So let's go to the project to do for a while. There were some things we added to the list here. So we can handle, yeah, we do that. We update this. And I think we fixed this last week on the stream, right? So if we go to our data and look at the example adventure and open up world.txt as our source file. All right, we can have objects lists. It can be empty. It doesn't have to have any. We have exits, which has to have some. Optionally, you can specify a background. All right. So that's done. Close that. We do need friendlier parser error messages, but we're not quite done adding all the features to this yet. So the next thing we need to do to fill in the room is to do the dig, I believe. So in our definition of the room, rooms are diggable things. So built into the engine, we have this verb called dig that lets you dig in a room. And if the author has specified that there is something to dig there, they can tell you what it is. Otherwise, you get some kind of error message that, like, you can't dig here or nothing happens. Which we could let the author specify. Or we could shortcut it, do the easy thing, and just kind of a hard-coded one. Which I'm very, very tempted to do, because that's like the easiest thing to do, parsing-wise. But let me show you what I mean here. So our room dig here, right, has an either text and otherwise a list, right, of text and maybe entity ID game object. That's because there's multiple things that you can potentially dig out of the ground. You might dig multiple times, so there's a list there. So it's going to be pretty tricky to do. Not impossible. And once we get that, then we're good for rooms. So how do we want to do this? Well, let's look at the world.txt file first. What makes sense? If I continue this pattern of these sort of property list things, could I do like dig here? Now, we have the two types here. All right, so maybe we should have... How can we do this? What would I even put here? Probably a list of objects, right? Like object references. All right, if I dig here, maybe there's like a jewel and I don't know, a mask, right? And that would fill in the list side pretty well. The structure, we'd have to manipulate the structure a little bit. Ooh, wait, that's maybe because when you dig here, I believe this text here is I'm remembering myself how dig works. The data structure isn't very descriptive of what it does and how it works. Handle dig. That will be in engine, I believe. Okay, so that's the fail message. Empty list. We have hard-coded, nothing comes out of it. You can still do it here, but nothing comes out of it. Success message, an item. Maybe item. Okay, so you don't technically have to specify an item. That's something new here that we don't really have syntax for yet. So we might need to have a new bit of syntax here. Instead of merely a object ref, maybe we need something a little bit unique. All right, maybe it is amazing. It can't be. And we could put like a little ref here, like the jewel. Right, so this could be like some amount of text, a optional separator, comma, some object ref. And that's it, inside these square brackets. We can have multiple of these. All right, and then you dig some more. And then, I don't know, mask. All right, that could work. Hmm. That could work. That could work. Because then let's have an example. Well, let's just have an example of the nothing case as well for our parser to work on. But how could we specify the failure case when you have no more error? No, yeah, a fail message. Like I said, we can either hard code this when we construct the room object from the parser, and the parser can just say, or we can do something else here. Another layer of syntax. And some kind of unique separator here as well, perhaps. The other thing we could do is separate this out. So maybe we have like a dig here and optionally a dig fail. Or dig end. Dig empty. Maybe something like that. And you could put your text here. And if the author doesn't specify, we could still put something there for them on their behalf. Yeah, that might make sense. It's only for this left case, which is when there explicitly is no dig available. So this would be, yeah, this wouldn't be dig empty. This would just be dig. So if they dig all this stuff up, they get eventually to the end case where it doesn't work anymore, and we have that hard-coded in the engine. So dig empty would be the, not dig empty, it would be dig fail. And you could specify text here. If you try to specify both, though, we can only use one or the other, because that's what the either is for. So it would be a parse error if we have a successful dig, and we try to dig a fail. Or likewise, like these have to be mutually exclusive. I think we can do that with the room parser. We'd have to try each of these and then have a check condition to see, to make sure they're exclusively defined. Otherwise, they would throw a parse error. I think we could do that. Do we want to make it explicit where you have to have a dig fail if you don't specify a dig? Probably not, because most of the time, most rooms probably aren't going to have it. Right. That looks kind of ugly. Having to repeat yourself a bunch of times for a thing you're only going to use once in a while. So I'd rather just have a default for it, I guess, is what I'm saying. Yeah. All right, so this should fail. If we have them both specified, you can optionally specify dig fail. If you don't specify dig, to customize the error message if you try to dig here. The floor doesn't exist. There is no ground here. There is no holy ground here. This is unholy ground. We do not dig here. Within another dimension, no digging, not allowed. Impossible. It's not holy ground. It would be terrible sacrilege to dig there. But in the main hall, we should get a parse error for this. But let's work on that. Let's work on digging first. And we'll work on dig fail some other time. Okay. So, to the parser, let's go. Get my world.txt up here. Okay, so this thing here, we're going to parse this little bit. What are we going to call it? Let's see. Not an entity ref. It's specific to dig. Called dig parser. And dig parser will be a parser of text to maybe entity ref. Of A. All right, I think that's what we want. And then we can reuse our property parser to get a list of these digs definitions. And that should cover that. Okay. So let's take out that single bracket, square bracket. Um, we could get rid of, trim off any horizontal space. Do I have like a trim function? I don't think I do. So we should probably have a little utility for that. Call it trim. I'll call it htrim just to follow the kind of the API conventions of this silly library we're using. Or wonderful library, I don't know. Depends on what you think about it. Yeah, so htrim, we're going to call many. H space. Not maybe, many. And it's gonna be, we're gonna void that. I wonder if there's a nicer combinator for that, actually. Optional, one or none. Like a version of many that just throws itself away. That's all I want. But I guess not. Oh, there we go. Skip many. That's what we want. Then I don't need this void. Skip many. So to get back to dig parser now, we can just htrim. So we'll get rid of any initial white space. Yeah. Add as much as you want. Then we got to get our text up until our separator. So I'm going to put a hole here. Do I have a helper for that already? Non-empty line parser. Almost. It only goes up to new line. But, let's see. Line parser. I almost want something like line parser, but just up till sep. Ooh, yeah. We might also be able to refactor this line parser in terms of this this parser I'm about to write, I think. What am I going to call it? Text parser? It's almost like line parser. Line parser by. We're going to take some parser of A. It's going to be like our separator parser. And then we're going to return a parser of text. I think we're going to write it non-empty. Because we need the text for the dig success message. Yeah, so that needs to be non-empty. So non-empty line parser by sep. Right, and it's almost exactly like this, except we replace new line by sep. Right, and now, if I move this, I'm gonna move this up here, and we can, I think this is going to be the same thing. Non-empty line parser by, and then we just put new line in here. That'd be nicer. Okay. I kind of want to test it just to make sure that I'm right, but I'm pretty sure that's right. Let's fire up the REPL and just make sure. Yes, we found the hole. I want to be fine with the hole. Okay, let's just comment this out. Right, okay. Test maker parser on here. Non-empty line parser. That should error out as left. Yeah. And if I, this should error out as well because there's no new line in there. If I put that in there, that should be fine. Yeah. So that should work. Okay, so now that I have non-empty line parser by, we can get back to dig parser. And we can get our success message. Non-empty line parser by, and this is going to be comma. Yeah, single comma. Then, after we get our success message, so I believe our SEP will consume that token, the comma, when it tries the SEP parser. So that leaves us with up to here. Now, one problem with this parser is that you can't have commas in your success string, which is a pretty common mark to have. So I think maybe we need to have something a little bit more uncommon. Maybe like that's sort of a double bar or digraphic type character. I don't know. That seems as good as anything else. Pretty uncommon to type that in a lot of cases, so for the most part. The other thing we could do is like leave it that way, but we could put quotes around this. And again, that means you can have quotes characters in your string either. We would have to have some kind of escaping for that, which is possible. But if I can avoid that, that would be nice. So let's go with the uncommon separator approach, and hopefully that'll work pretty well for us. So let's, instead of single quote like this, we should do string. And like that. All right, then we htrim after that. And then we have our entity ref optionally. So we can try the entity ref parser. We don't have to have it. Maybe entity ref. And I think that's optional. Um, I don't know if optional is going to be the right one. Option might be good. Not some or many. Let's try optional. Optional might be the one. Optional entity ref parser. Well, it's not unhappy yet. Doesn't mean we got it right, but now that we have the entity ref parsed, we want to htrim one more time. Single closing bracket, and then we return our success message and maybe entity ref. Yeah, okay. Let me, all that humming and hawing about optional was not a problem. Let's just do a quick test here. Let's test dig parser. You rock. Yeah, it has to have at least our double bar. Right? No, it doesn't like it. It's hanging. Hmm. Hanging because... Why is it hanging? Well, in the full case, let's say we get this. We don't like. We don't like. Okay. Let's try, oh well. I'm just gonna make sure htrim works. Could be the htrim. Skip many. This one I always find is a little bit to use. It's almost like it almost wants, it's like it's super eager. I don't know why it's failing to finish though. That's kind of... All right. That, I kind of expect that one to work. Is H space? Does our H space function maybe take up one or more of our input white space? Maybe. That could be it. Let's look at the packet, megaparsec, I think it was in. Might have been in car. Yeah. Like space, but does not accept new lines and carriage returns. Okay, so space will skip 0 or more. So we don't need the skip many on here with htrim. Looks like. I thought it was just one. H space, and H space. Okay, recompile that and just do a little test. Okay. That works. If we get rid of our entity ref, that works. We have no entity ref. That doesn't, because we need at least that double bar. Which is kind of what I expected. Could we make it so that if you don't specify the double bar, it just means nothing? That would be tricky. Because the non-empty line parser by needs a separator parser. If we try like optionally this one or the close brace. All right, if we determine that we've seen the close brace, we have to end the parse early. And then we won't know if they're what the state we're in. Right, because if I go back up to non-empty line parser by, sumtil is going to try this sep parser here, the separator. Right, and when that succeeds, then it knows that it can terminate and then return its result. But I don't think it peaks at that. I do think it consumes it, but we should probably check. All right, that's sumtil. Yeah, end result is consumed and lost. It's based on manytil. Yeah, and so I think it looks like it runs the end parser and just ignores the result. Otherwise, it continues and tries to parse more. And it tries to parse P again, collecting the results. So that's going to make things a little bit confusing and difficult for the way we've written this so far, without peeking. Is there a way to peek? I mean, if we can do it with peeking, then maybe we should do it with peeking. Okay, back. Yeah, peeking would be like looking at the input without consuming it, just to see what's there. Some parsers implement it, some parsers don't. I don't know if megaparsec does or not, because I haven't really used this library a whole lot, except for on this project, so we should probably look that up. Search peek, look. Okay, try behaves like the parser P, except it backtracks the parser state when P fails. So this is used whenever arbitrary look-ahead is needed. Okay, so this is probably the approach we need to take with megaparsec, I guess. Oh, we have look-ahead, actually. There's another way. So if P in look-ahead succeeds, the whole parser behaves like P succeeded without consuming anything. It will fail consuming input if P fails consuming input. Okay, yeah, so I think maybe we could... What could we do? We could try... We could try parsing them as two distinct things. It's like we could try parsing either just some text, no refs, as one thing. And if that fails, we can try our just some, actually some text. And our entity ref. All right, so we can try this one first. Otherwise, try this one and see if that one succeeds. All right, so that means we're going to consume all this input up to here, up to somewhere. And if it fails, we're going to backtrack the parser state and try again. And we'll try this one. And if that fails, then we fail the whole parse. Input consumed and all. I think that might work. So let's try the... So we have like a simple dig and we have, or what do we call it? Like the no item dig and an item dig, or simple dig and item dig. A empty dig and just item dig. Basic dig or item dig. That's fine, I guess. So basic dig parser. Be a parser of text. Nothing. Oh, sorry, that can't be nothing. That's got to be... It's still got to be maybe entity ref of A. Leave it undefined for now. And item dig parser. Be a parser. Same type, really. I probably didn't mean to yank that, but let's... There we go. Item dig parser. All right, this becomes item dig parser, really. That one can be undefined for a second, because dig parser then becomes maybe basic. Try basic dig parser. And case... What is maybe basic here? There's got to be a do block. So maybe basic in this case is actually what was parsed by the basic dig parser. Oh, okay, and then we got to use it with this OR combinator to try the second alternative. Okay, so then this becomes not quite like this. We can do it as try a basic dig parser or item dig parser. And that would check fine, assuming that we can implement basic dig parser. Okay, I think that'll work. So let's try this. So that'll be a single open bracket. Some H space. A success message. It'll be a non-empty line. Parser by. And in this case, the end will be the close brace. So this just means now that you can't have those square braces in your text. It's probably fine, I hope. Now that I'm looking at it, I'm wondering if maybe we could put a limitation on the success text message here. Single sentence, we separate by the period. So instead of having this fancy syntax here, but then we'd have to have it like this. Yeah, it's ugly too. It's just we have to end it with something. Maybe like that. And then nothing is what we hard code here. Maybe, no, maybe it's more like this. Does that parse properly? Yeah. Yeah. Okay. Will this work? Maybe. I have my reservations, but we'll try it out in the REPL here just quick and see what we think. Yeah. Let's see. Test maker parser. Let's try the basic dig parser. This is the one I'm kind of like, I don't know. Bar and Baz. No, it doesn't there. Yeah. Parse error bundle. Trivial error. That'll fail, but if we put some spaces on the end, will it work? No. Okay, and that probably won't work, I suspect, because this sep parser here is probably just a little bit too much. If I take off the H space and we go with just single this. All right, recompile, pop over here. This will fail if I have the spaces. Oh no, it'll work there. It'll just have the spaces on the end and nothing. Which we can fix just by having t.trim, I believe. If it has it. Strip. Strip, strip. Okay, so that'll be fine. And just means like if you wanted to have square brackets in here, that won't work. It'll get weird results, apparently. Right, if you get this, you'll get unexpected results. It would be nice if we could turn that into an error. But it's... We can't quite do that with this because, again, sep is going to get... we're going to consume all of the Latin characters up until we get to this single closed bracket, which is technically a success as far as non-empty line parser is concerned. And yeah, that means that's not quite right. Not quite what we want here. What other ways can we do this? We could we write non-empty line parser so that we consume those Latin characters, but sep doesn't consume its input. Could we detect that state if we, no, because again, no, we can't detect the state. I was thinking maybe one way to do this would be to consume this input and then ask for H space and another single close brace. But that wouldn't work. All right, we compile that and try it. All right, we get, well, we do get an error. But in the case we expect it to work, I don't think it'll work either. Again, because the separator in our non-empty line by consumes. So let's see if we can write a non-consuming version. Maybe that's our solution. Call it non-empty line parser by prime. Oops, link, not link, line. Here we go. This will be sep will not, sorry, that's a different syntax. At, I think it's that for literals. Sep will not consume its input. So this will be like non-empty line parser by, except all right, now assuming that works, then we should be able to write this basic dig parser like this. And then we should be able to demand h space and a single closing square bracket and expect this to succeed. All right, that would make this an error. That would be an error. This wouldn't be an error. So it'd have to be, That's fine. Actually, that's fine, because as the parser proceeds, this would be fine, yeah. This would be okay. If the parser proceeds and like there's other parsers we're combining here, they'll consume their input and they'll see like, oh, there's a parse error and we'll get the error in the right place, yeah. That's okay. So this approach will work, I think. Let's see if it will. So I'll need something like the implementation that we were looking at for many-till. But instead of end here, we would just make that try, I guess. I think even lower level. Yeah. Might even go lower level. We'll have like many till. Almost the same definition. I want to see if this will work. Just gonna put a tick on it. And instead of end here, we're gonna just try end. I have to import that to make that work. Oh, it's in not dated all alternative, I don't think. It's oh, where's that package? It's foldable, right? No. Control.applicative. I think that's where it's from. Let's see if I'm right. Control.applicative. Yeah. Problem with this. What's the problem with this? Could not deduce monad parsec from our use of try here. Two arguments for monad parsec. Okay. Three parameters. Oh yeah, error, E, S, and M, the error, the state, and the monad we're working in. Okay, so that type checks. Maybe it works. So then I'm gonna grab our GIP implementation or sumtil. And put a tick on this. We'll do the same thing probably because we'll need it. Monad parsec. And this will be many till tick. That looks good there. So then we basically have the exact same implementation here. except we have some tiltic. Okay. Let's compile that, try it out in the REPL, see how we do. That works fine. This we said should be an error. It is. And this should be an error over here. Okay, that's looking pretty good. That should succeed though, but it doesn't. Let's try, that doesn't work. Okay. The sum till tick. Actually, no. Non-empty line parser by tick. And we'll give this an argument. Yeah, like this. We'll give it single. Okay. Now, the thing is, I want to see the actual parse state. How can I run and see that I want to know if our little character here is still in there. Could we run this and then run single like that? No. Let's see, this one's not doing so hot because it looks like it is still consuming. Like our attempt to use try here might not be doing what I think. Or what I was hoping it would. Still closed. Still closed. Try. See, I was hoping it backtracks the parser state P when P fails. Oh, only when P fails. Right, okay. So if it still succeeds, it still consumes. Okay, so try is not what we want. Maybe look ahead. And look ahead succeeds. Right. So then the whole parser behaves like P succeeded without consuming anything, though. If P fails, look ahead has no effect. It will fail consuming input if P fails consuming input. Combine with try if this is undesirable. So I think that means if it fails consuming, if this fails, we don't want, yeah, maybe we want to look ahead. But I'm thinking the failure case might be a little bit. We're compiled. Yeah, okay. Let's try back to basic dig parser. That's good. That should pass. This should fail, but it doesn't. Why doesn't that fail? Mm-mm. Not what I was hoping for there. Hmm. Almost. Almost. Okay. So this isn't quite... It's a little too okie dokie. So we do our basic dig parser here. We get our separator single here. Parses up until that. All right, and that's, so that would work in this case. We're getting the strip down. The text here, if we take this out, we should see spaces on the end in that case. Right? And there they are. Happy little spaces. So if we put that back in like we want, let me run this again, that's that. We want it to fail here though, because we get through this parser, go back to dig. All right, the success message, non-empty line parser by prime, right? So it should go up to here, up to here, up to here, up to here. Single, right? It tries it, looks ahead, tries it, succeeds. The look ahead shouldn't consume it. So we're hoping that look ahead will succeed. That'll be fine. All right, so then our parse state should end here. And this is where I think the problem might be. All right, and then we demand H space. That's fine, 0 or more. Then we demand a single race. Oh, look, it's there. Okay, then we return. And the rest of the parse state is the rest of the string. So it's not quite right. But we'll get a parser anyway. You know what? This is good enough, I think. Because if we succeed here, all right, with dig parser, we try the basic dig parser, that works. It's not exactly what the user intended. But we're using this technically in the middle of, say, a property parser. So the next thing we would expect is whatever the separator is for that, which will probably be a comma. But let's just say they're super hostile, and they wrote something like this, which would be quite silly. So they would get the separator, and they would try another item dig parser, or dig parser. And then it would fail here. And that would be fine. And we get an error. You didn't fill out the property properly. Yeah, so letting it succeed there would be okay. And in fact, all of this, don't consume all this stuff, might actually be overkill. Now that I'm looking at it. We can just, yeah, just take the tick off there just to try it the other way. Use a regular non-empty line parser by. That consumes this square bracket. Right, so we're saying this is okay. So now that I've compiled it and run this example again. Yeah. Okay, so maybe we do need the tick. Yeah, so we still want it to succeed. We still want to consume that end input, even if things we're just looking for this to be like a terminating, non-consuming. Actually, no. No. Actually, let me take that out. This demand out here. This is what we meant. Yeah. Okay, that works fine. It does mean you can't have square brackets in your... whatever. If people really want it, we'll have to implement escaping. No biggie. So yeah. Okay. That's fine. So we can try the dig parser. And that should succeed with what we have so far. And the other dig parser we wrote. All right, so if we have the separator in here with our, this should succeed as well. Uh-oh. No, it's eagerly finishing. So maybe we should try the item dig parser first before the the basic. Greedily try that one first. And then the easier one second. There we go. Now, if someone wrote this, they're going to get in some weird things, but then again, we'll get, hopefully we'll get proper parse errors, because that would be malformed. Weird. But we did get a successful token here. No, again, too eager, too eager. Oh, it's treating this as part of the input text. And still parsing out the, which is fine. That's fine, that's fine. What if we did this? That's fine. Yeah, anything there. As long as you have those double bars. Right. Probably have t.strip on success message here as well. So there is a case where you could have double bars. Sorry, bracket. You got square brackets in your success message if you really wanted to. And what other ways can we mess around with this? Well, that's just going to be a Haskell parse error. So, yeah. Okay. And if we don't have that, okay. So then we get the normal, the one we want, the basic one. If we try to do double like that, still get something meaningful and useful. If we try to do this, it parses it as a basic. Ew. Don't like it. Yeah, I don't think we're gonna do this with combinators this way. It looks like we're gonna have to like dig in and do like a proper look ahead for our double bar character. All right, so we'll be consuming, so put consume a character, consume a character. If we can look ahead to get this, if we find it, then we know we have the one case, right? And the next thing we should look for is the proper entity ref. And if we get to a closing brace before we see this, then we know we have a basic, and that's fine. And then otherwise we just keep going until we get an error. Then we'd run into the infinite parse problem. We never encounter these characters. All right, so we take out the double bars and the closing bracket. We'll eventually hit the end of input, but we'll consume everything and just be like, we still haven't found the closing one, which I guess will happen anyway. So, okay. How much time we got? About 15 minutes. Okay, dig parser, you're so far no bueno here. I like some of what we've written here so far. I don't want to throw it all out. Just this hunk. Well, jury's still out on this hunk, but we'll leave it for now. Okay, let's try dig parser part 2. So this is going to return the text and maybe entity ref of a. Okay. So we always have to open with our opening bracket. Sorry, single. Make that a square. Although we have the section parser. That'll be fine. Square's fine. Whatever. Anyway. So after we do that, we can H space. And then we start consuming input here. No, maybe I'm wrong. Maybe we could still do it with the parsers. Let's try success message like this. And non-empty line parser by tick with our sep parser being first. Try the closing brace. Or string of our double bar. And then we can H space do our maybe entity ref with optional entity ref parser. And then H space again for good measure. And this isn't going to work because we want to have, if we get to this case here with success message where, let's say single closing bracket succeeds, right? That means that non-empty line parser by prime should finish, returning the inputs consumed. So in this case, the text is consumed so far, and leaving that square bracket on in the parse state. Like that'll be at the head of the string, whatever that we're still parsing. H space, so 0 or more horizontal spaces, there aren't any. So then we go to this parser. Optional tries to get an entity ref. Fails and returns nothing. Because we just have this character at the front still. 0 more H space. And actually, maybe this will work. Huh. Maybe it will. We'll t.strip that success message. And we'll return maybe entity ref. Here, maybe this will work. If it would compile. Um, oh, it's got to be the same parser type on the alternative. So we can't parse either a character or a string. Maybe it'll be fine if I do it this way. And now we get redundant dollar. Okay, there's some little cleanup bits there. Okay, maybe this will work. Okay, so that's the case where, yeah, we don't have any double bars, so this should parse everything up to the closing square bracket and succeed. If we put the double bar in here, this should fail. Yeah. Now, did it fail for the right reason, though? Let's put a good one in. No, it didn't fail for the right reason. Dang. Close, close, close. So, let's see. It's failing on, let's see, 11, 1, 2, 9, 10, 11. Hmm. Okay, so if we walk through this one, right, we consume that one, then the H space, and then we start the non-empty line parser by prime, which will consume this character, this character, this character, this character. This one, the space as well. Now we get here. We're going to try sep at some point, right? This one's going to fail. So then we're looking for the string dot dot. So eventually we're going to consume that and stop. But this is non-empty line parser by prime. So we're going to actually undo that to here, where I have my cursor. And then H space, yeah. So in this case, we might not want line parser by prime. That works good. That doesn't. That will. Because now we're consuming the input. So this part here should just be optional. Or we have to tie it to entity ref parser. Yeah. I think we can do that. Kind of wrap those up there. And the idea on this here is this comes from functor, I believe, where it'll run this action on the right but ignore its results. The main thing we're concerned about is this. But we're getting a type match error. Yeah, I'm probably just doing something a little bit too fancy. So if we get to the after this, 0 more 8 spaces. Well, on this branch, we consume that close bracket. We consume 0 or more spaces. And then this stuff. But if we don't consume it, so we use prime by, then we don't consume it in either case. Then we don't know when we get to line 152 whether we have what we have. Do we have this branch or this branch? Do we have the square bracket or the double string, the double bars? Because line empty parser prime will leave that there without consuming it. Could we do another look ahead? Yeah. So, I'll just fry my brain a little bit here. I think we're almost out of time. That's the chief problem with this, though. So either we have to look at what's on the if we leave it on there, we have to look what's on there to know if we need to, if we can return early or what. Try. Not quite. Not followed by P. Only succeeds when the parser P fails. So what would we rate? That would be like not followed by. Observing allows us to observe failure of the parser P. Okay, so without actually ending parsing. Okay, so we run the parser, we get the either parser on the left, or the result. On success, the parsed value is returned in right as usual. Note that this primitive just allows you to observe parse errors as they happen. It does not backtrack or change how the P parser works in any way. So observing the failure. No. Our original idea of having the two parsers separated out and using alternative had the problem that our branch was just a little too greedy. Our syntax was just, yeah, it was hard for our syntax to not be greedy, I think, was the thing. Let's look at world.txt again. So we want to be able to handle these two cases just fine. The problem with this is that if we use the naive parser, say the one on the right here, where we don't have the double bar in it per se, and then we need to fail this. We need this parser to fail if it encounters the double bar. And then we can try backtrack and try this where there is a double bar. That could be a way to do it, actually, maybe. Okay. Let's try that again. Basic big parser. Okay. Parser. Text. Maybe entity ref of A. And I'm going to copy most of this. I'm going to H space after that and demand a single closing bracket character. This doesn't become optional anymore. And this becomes, well, maybe entity ref, just entity ref. Then the non-empty line parser by, we don't need the tick one. We have the string like that. So we consume that string when we encounter it. So then no, this is our item dig parser, sorry. Item dig parser. Our basic dig parser is parser like this. Okay, and the difference being that we're gonna terminate early in the basic dig case if we encounter the double string. That's what I'm gonna try here. There's not gonna be any entity ref. Base. Success message P. And this will always be nothing. Now all we need to do is make sure that success message P fails if collects together each of our text characters in our character set, but checks first to see if we have the double bar. So it's almost like these, many till or some till. I wonder if we could pass in our string parser in there for that. All right, pop over here. Oh, sorry, no, basic dig parser. Right. It does need to fail if we encounter a string. Otherwise it needs to collect a resist. I think we have we might have a combinator for that. Take while or unless. Not in here. Where is it? Take. Where is it? Is it in car? Maybe it's in car. Take. Let's take while P. I thought we had that somewhere. Where is it? Google. Where's my take while P? Is it in there? Yeah. Okay. Take while P. Parse 0 or more tokens for which supplied predicate holds. Try to use this as much as possible, because for many streams this commenter is much faster than parses built with many and satisfy. So token to bool. That means we can only look at one character at a time for that. And this is all token stuff. Eh. Any... Not satisfied? No, no. Yeah, so we can consume input until we see a bar. And if we see a bar, then forget it. Mm-hmm. Satisfy. Take while. P. Take while P. Something like that. Take while 1P. And this function here. And what do we need to put in that hole? Maybe string. Oh, name for a single token in the row. Predicate, and then our predicate, F. Okay. Just nothing. Well, our predicate F, though, is token text to bool. Not equal to bar. This failed because, yeah. Get to that sec. Okay, so maybe that worked. Then our dig parser we can go back to that idea of trying the basic dig parser first. This is the one that can fail, and we expect it to. Otherwise, we want to do the item dig parser. Now, hopefully they won't overlap this time. That's not the right type. Parse error. Parse error. Parse error, parse error, parse error. No. Okay, let's try the basic dig parser. That one's failing. We kind of expect this one to pass. Just end of input. Okay, take one while P is being stupendously successful. And taking everything. Yeah, so that makes sense. Maybe we can... non-empty line parser by tick with our single all right, it's not going to consume it. H space, get rid of this. Okay, now, but the problem is now we have overlap. God damn it. Well, you know what? We could actually, let's just cheese a little bit here. Actually, you know, I'm thinking about it. Just came to me. What if we just inspect success message and just branch on it? If it contains this character, no. All right, so we'll make it consume everything up until the single whatever. And then we'll just do if is there contains, like a t dot contains? Data.text. Right? There's element. Not the folds, not the constructions, not the unfolding, the substrings. Searching. There we go. Find. Okay. Find might be our friend. So we want to find if it is equal to bar in success message of, and if we find it, doesn't matter what it is. Invalid basic dig success message. Otherwise, we're good. And let's return. That was successful, and now, hopefully, our first one will also good. Okay, cool. And we don't have overlap. Okay. It took a while to figure it out, but we did. And there you go. So now that we have the dig parser, are we using any of this code? I don't think so. Yeah, so we're not using many till prime, some till prime, or like that. But we still compile. Everything looks good there. Just fire up the game. Projects, adventure engine. Who doesn't like a nice adventure, right? Okay. So this is what our project looks like. Adventure engine, exe. Everything still looks like it's working. If I can get the window focus, that would be great. I don't know why the input isn't working. Oh, there it is. Pick up the shovel. We can walk through the front door. And drop the shovel. All right, look in Brawley bucket. Cool. Take Brawley from the Brawley bucket. Cool. Walk through the door, drop the Brawley. Yeah, things are looking pretty good. Okay. So that's good. That means we don't do we use, yeah, we use complicative still for the or. Okay, so I'm gonna stage that. Yeah, we'll add that just as is. Add dig parser, maker parser. Not the best description. Let's be a little bit better. As the following parser that can handle success message or success message entity ref change doesn't add it to the room parser yet. Hey, IsoVector, what is happening? What's main today? We are working on an interactive fiction engine. Actually, like what's main today? What's main today? That's a good one. Even though it was a mistake, it was great. We're working on an interactive fiction engine that I've been working on the stream on for quite some time. It looks like, don't mind my garbage programmer art, but the UI doesn't look pretty yet, but it's here. So it's a graphical text adventure game engine. Tonight we're working on the authoring tools. So the engine will takes a zip file that has all the content it needs in it, parses it all out, and starts running the game. I'm doing the authoring tools that'll like create the zip file from a source text and some images and stuff, so you can make your games without having to edit JSON files, basically, and then zipping things up just right. So you just write your game engine and your game in plain text with your images in a directory, and then just point this tool at it, and it'll just zip everything up and all that stuff. So I just got that dig parser working for that. Where's my example file? I closed the buffer, so I'm going to bring that back up. So that's our example file. Now we just need to, now that we can parse these little parts of the dig, we can hook it into our little property parser and implement that part. So that will be in the room parser. All right, so that whole block from this hashtag, this hash down to the next one, skipping this one, sorry, down to here. So this whole block here is one room. Right. This is a heading for a section, so these will this section parser will parse out all of these rooms with these entity refs and stuff, and all this metadata about the room in between. So we know how to do this kind of property thing. We've done it with exits and objects. Dig is optional, so we'll use the property parser for those. They can come after BG. I'm not super satisfied this is like order dependent, so that you have to define these in the right order for the parser to work. But it's a little bit, I'm not sure if I can figure out how to make that work, but maybe, I don't know. Lahoozle, let's do the simplest thing, the dumbest thing that works, and we'll figure that out later. Digs. This one is optional. If we don't have it, it should be nothing. And we do property parser of I don't have a type alias for it, so I hope this type application will work. Maybe I should just write it as like a type digdef. As a text and maybe entity ref a. Maybe that'll work. I'm not sure. Why not make a proper type? That's true. Smart. You're so smart, Isovector. I love it. And we'll have to give it the label, which will be dig. Yeah, because that's not, I had a suspicion this wasn't going to work because of that there, so I think you're probably right. And I was complaining earlier on the stream about it being kind of a nonsense type, and I had to go look up what it actually does by looking at the code. So thanks for the reminder. Yeah. Type synonyms generally, I agree, are very rare instances where I find them useful and good. So I'll have to dig into the engine. Let's define it here. I don't know if I want to do this refactor right now, though. Okay, okay. Hopefully this won't take too much time. So yeah, this will be dig definition. Be a dig definition with get dig def, which will be just this type here. Then we replace that with dig definition, and everyone's happy. Just gonna pull this over to the left a little bit just to make it a little more readable. Yeah. it has to have a show instance. I don't have deriving strategies on, so we can just derive show from a new type here. Then I need JSON instances for it. Means we're gonna need generic. Let's not spell it right. Oh, I did. Yeah, go. Just catching up with me there. Okay. So then all my type errors come into play. And for some reason, my editor is going to show them to me, but it will tell me down here. On 679. Blah, 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 blah. Okay, so I am pulling out the tuple here. I think I can just wrap this here. Dig a definition. Which I need in scope. No. Just a redundant bracket. Okay. Good. Doesn't hate me. Is there a reason that I'm making this a new type instead of data? Not really, no. I wasn't thinking too hard about it. Could easily be the other and be pretty much the same. Might even be better. Yeah, because then you could label the parts. Okay. Step 2. Will be to make this proper. So dig success. Dig definition success is a text. And dig a definition object. Game object. Is it maybe? It's optional. Change this to data. Okay, now we're a little happy with this. Just have to change how I'm destructuring it to get rid of the tuple. Now we probably will need the braces around that. Or sorry, parentheses, sorry. Herp. 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 What the? Why does my thinks I don't need that for some reason. Okay. Maybe it's just me. Okay, then we're back to just the typer and the parser. That wasn't so bad. So then the dig definition here is good. Except our property parser isn't quite right. Right, so property parser only is explicitly parsing entity refs. We could probably make this a little bit more generic so it can handle any list of properties of different type that we want, and then redefine property parser in terms of that more generic one. It's probably a little better. So yeah, we'll go text for the label, parser of entity ref. And no, parser of some kind. A. Yeah, and then we replace entity ref with A here. Yeah. Take P as an argument. And then we set by here, we replace entity ref parser with our slightly more generic one, P. And entity refs as a name doesn't really make sense anymore. Just call it P's. And then we can have entity ref property list parser. It's a mouthful. That one could be just text like we had before. Parser list of entity ref of A. Look at this, making everything so much better. And that one would just be property parser of label and entity ref parser. And this is getting to be a little bit sprawling of a change, but it's almost there. All right, so this isn't necessarily property parser anymore. It's entity ref property parser. That's what I called it, right? Property list parser. Now we can use something else here for dig definition and all that stuff. We need one for the parser one side of things. So similar take on that. P, we know how to do this, right? P's P. So entity ref Probably could have done this inline and saved the extra definition. I don't know. Let's see if I like it. And this will be property parser 1 with label and entity ref parser. Okay, so we go back to room parser, and we can just update our room parsers now. So this will be entity ref property list parser 1. And we can do a quick comparison here, I think. So I have property, this one doesn't need parser 1, it could be 0. I think. Yeah. So property parser of dig definition on dig, and we want to use the dig parser. Don't think we need to put that type application in there for it now, though. What did I do? Property parser. Yeah. Yeah, so we pass in P. Label in P dig parser. What's the type error? Oh, dig parser. That's right. Dig parser is still returning this cat. This is where our this is going to get slightly annoying here, because entity refs are like incomplete references. They're not entity IDs because we haven't established that they exist yet while we're parsing. That's going to come in a later step in the parse. So this is where I do need something that's similar to, maybe I can update the type for dig definition, right? The idea is that right now, like, I want to parse an entity ref of game objects, and this one is an entity ID of game objects. I could still parse it this way. We just need actually just a transformation functions to convert it into proper dig. So let me turn this into a dig definition. Yeah, I think we'll be able to do this. And maybe game object, dig game object. And we'll just use the constructor here. I didn't type it right. There we go. And I didn't type it right again. Getting close to the end of the stream, you can tell. Right, so Actually, yeah, we can't do that still. That way. Yeah. So we can parameterize dig definition with our. Is that that's legal Haskell, right? But now we have to tell all the sites that use it which one we mean. Which aren't many, fortunately. So when we construct an actual room, we want entity IDs. I don't like where that's going. Don't like it. Don't like it. Don't like it. No. Backing out of that. So I just need like an interim dig definition, something that's similar to a dig definition, but just replaces that one part of it. And then it's purely for validation purposes. How am I doing this, the room parser here? Yeah, we are turning them to IDs in here. Yeah. Because the entity ID is just the phantom type, and the number containing can be anything, and we're still going to validate later on that all the IDs are consistent and make sense. Okay. So I think that'll be fine. Yeah. So the dig parser can still return the dig definition. We just have to convert this to entity IDs. All right. And then what do I get in that hole? An entity ref A1 to an entity ID game object. All right, I can put a little function in here. Entity ref X. Oh, it must be like entity ID X. Oh, the type, right. Well, it's just X. Yeah, so that function is just the entity ref entity ID. Yeah. Okay, and okay, cool. Then we're back to here. So option, I think we should do this. Not optional. It's optional. Okay, and then we don't use digs. All right, so the room dig is an either. This gives us the right-hand side of that. All right, now the type of digs is maybe list. All right, so in that case, actually, we can do maybe pull it apart and give it left the default thing. We'll fix this later. We'll give the left right there for now. Otherwise, in this case, we want to wrap that in right. And the maybe we're going to be operating on is digs. So later on, I want to be able to do that validation I was talking about at the beginning. We were like talking about this tricky kind of parsing, where we want to have like mutually exclusive. Either you can define the success message or that failure, dig failure property. Right. If you want to specify it. And then in the very, very last case, where we have neither of those things, we should fill in our default left. You can't do that here thing for that. But I'll do that in another change. This is enough. As long as it compiles. That's good enough. Yeah. Okay, so that means now we should be able to parse this file and everything should be hunky-dory. So let's just do that quickly and check it out. I'll bump up to here. Okay, so the way we do that is with the Adventure Maker command, or program. And we give it the folder, example adventure. That seems to have gone well. Let's open a buffer to that. Actually, I gotta cd over to it and unzip it because it creates a zip file as an output. So unzip it first. Let's see. I'm gonna go to build. There it is. Unzip game.zip. Okay, and it's just got the world.json in for now. And we should see our digs definition in here. There we go. So when the room is defined and the dig is defined, there we go. We got right. Right, the object that you dig up if you're successful, the message you get when you dig it up, so on and so forth. In the case where it's not defined, we just don't have it, which is great. And we parse all 3 rooms successfully without interruption, so it's great. I say it's worth committing this code. Add a dig property list parser to make a parser. So a new option, property list as being added to room definitions. Dig. Basic dig. Dig with item ref. And I know it's word wrapping, but whatever. There you go. Cool. That's all the energy I have for tonight. We went a little bit later than I usually go, but if this is your first time tuning in, I do these streams on Tuesday nights, and I mostly work in Haskell for the most part, almost exclusively, except for that one time that isovector showed up and I was doing JavaScript. I'm sorry, isovector. You'll be happy to know, though, that that game that I was working on did place pretty well in the competition. So one thing I'm kind of debating with it is that I got some really nice feedback on that game. And I'm kind of debating doing like a proper version of it in Haskell, maybe? I don't know if I should. Because I have reservations about doing a game in Haskell. One of them being that I know it's possible. Like, it's such a simple game that it wouldn't be very, very hard to do. And it can be done. And it will be playable on all the PC platforms that can run Haskell programs, which is all of them. Right? And all the ones that have the SDL libraries that you need to do a game. Right? The problem with it, though, is that any other platform not supported. Right? So let's say we make this game and people really like it and they want it on the Switch or they want it on the PlayStation. Dreams beyond dreams, and this is like long, long down the road, right? Probably won't even get there. But if it did, other indie game studios I've seen that tried to use Haskell, this is where they fall off the cliff. Because you have to port Haskell's runtime to those platforms, and they are all under NDA, so you can't necessarily share that. And this is the problem you would run into if you used a game engine that didn't have an exporter for that platform too, like say Godot, right? The solution to that in Godot is that you hire a company or you buy their solution, right? So they might have an exporter, proprietary exporter for the Switch. But that doesn't exist for the Haskell ecosystem. So if it got to that point, I'm not saying it will, but if it did, would it be worth it, knowing that that might take, who knows, how many months or years to do that port and get it running on the Switch? And then not being able to resell it, because like the number of people developing Haskell games for the Switch platform is probably going to be me at first, like So, I mean, that's why I'm kind of like, I don't know if I would do it in Haskell. But yeah, so I don't know. I might do it in something else. I don't know if this is going to go to this year's winners where mine is. No. Okay. Death, 15K. Yeah, there it is. So 121, not too bad. All right, and it's a pretty straightforward game. It's not so bad. It's got sound. Pick up little souls. All right, it could be like, and like people have left some pretty nice feedback on it that makes sense. Like a lot of the suggestions I've heard are pretty much what I had in mind for it too. And it would be maybe like the scope of Vampire Survivors or something like that. You know, like a few power-ups, not a really difficult control scheme, pretty simple to play. Like this has a bunch of flaws in it, like doesn't have any screens and you don't know all that sort of stuff. But anyways, I'm debating it. I don't know. Maybe I would do it on the stream and we could do it in Haskell. We could build this game out together. The other reservation I have about Haskell games in general is that of coming up with the timing. Like I'm still, I don't know how to do that exactly. Or like you want fixed interval time step loop to happen. Obviously with garbage collection in there, there's a possibility for pauses, but I'm not usually too worried about that. I don't know, I think Haskell's garbage collector is probably good enough. Game engines like Unity use C#, which is garbage collected. Unity is pretty well, it's occasionally optimized, it's pretty well optimized for what it does. And if you use C#, that's usually really good. I don't know if like, I think the .NET garbage collector probably has a lot more work put into it, maybe, than GHC's. Maybe, I don't know. So debatable. It's possible though. It's within the realm of possibility. But yeah, so like collecting the fixed time step loop is like collecting all together all the physics updates if there's room still to do it before you render a frame. Stuff you can do in C pretty well, which is what I'm used to using for game development. So Haskell was a little bit of a risk there where I could get mired down in the complexity of figuring that out. But you never know. So there's that. And yeah, these are the sorts of things we work on this stream. Non-trivial projects where we figure stuff out with Haskell and we build stuff with Haskell just to show folks what it looks like, have fun doing it, and not just do like Hello World tutorial type levels of Haskell's type stuff or like academic exercises of like figuring out type hockey and stuff like that and type Tetris. Although sometimes we play with that a little bit. So if you like what you saw tonight, give us a follow. If you're following me on YouTube, you know what to do there. And I'm Agent Ultra. The code for this project I showed is on GitHub and under my name at Adventure Engine. And that's that. There it is. It's I already have the tab open. It's Adventure Engine. You can also follow me on Twitters and on types.pl in the Fediverse and elsewhere. So thanks for tuning in. See you next week. May all your monads be free and may your types always check. Peace out.